All right, let's talk about it with the, what's that, 20 and 25, 45 minutes we got. Okay, so here we go. Carli and Dale. Oh, I was going to run, I always forget. I was going to find out which ones you missed with the thing. I forgot. All right, whatever, here we go. We'll try to go over it all. So, $18. $18 is the total cost of the cake. And Carli values strawberry and banana equal, but chocolate. Oh no, we've done these. Mm-hmm. We've done these, right? We can kind of skip some of this. Is that okay? Or how about I just whip it out super quick? Remember, you want to divide the chocolate in half because you want them all to be the same sizes. We have these on quizzes and stuff, huh? Want them all to be the same sizes, okay? And then we'll do the Carli thing first. I'll just do it super quick. Carli values strawberry and banana equal, chocolate twice as much. So strawberry, banana get an X equal, right? Chocolate twice, right? Chocolate twice. So that's 2x, 2x. Each of those get a 2x, right? Because that's what it means to value a flavor twice as much, right? If you value the flavor twice as much, then it's also double size. So altogether, it's going to be 4x up there for the chocolate, right? Because you like the flavor twice as much, and there's twice as much of it. That's a 4 times overall, right? So add that up then. X plus 2x plus 2x is 18. That adds up 1 and 1, and that's what, 6? 4, 5, 6, yeah. 18 divided by 6, x is 3. So go back and put in that 3 for x everywhere. So this is 3, 3, 6, 6. Add that up, that's 18, huh? 12, 15, 18. That's the $18 cake in Carli's eyes. That's how she sees it. So the strawberry quarters were $3. C. Now, that was all the Carli cake. Now we got to do the Dale cake. So all that's for Carli. Now we're going to do Dale. So I guess I'll erase this, or maybe I just do Dale in another color over here. All right, so I'll do a Dale cake here. So how does Dale feel? This is strawberry over here. It's chocolate, and vanilla. No, banana, whatever it is. Banana over here. All right, and what does it say about Dale? Chocolate 3 times strawberry, strawberry twice banana. Remember, you start with the lowest one. Lowest one's banana, right? So banana X, strawberry is twice that, 2x, and chocolate is 3 times strawberry. So that's 6x, 6x. Did you follow that? Right? Because it said for Dale, bananas is least, strawberry's double. So 2xx. And then chocolate is 3 times strawberry. So that's 3 times 2x, 6x for each of those chocolate sections. Add all those up. And what do you get? What do you get? You get, I guess it went out. 6x, 6x, 2x, x adds up to be $18. 12, 30, 40, 15. 15x is $18 divided by 15. X is, what's that, 1 and 3, 1.5, 120, $1.20. X is 120. So then you got to plug that in. So that means this is 120. This is 2 times that, 240. This is 6 times that, 720, 720. Everybody see how I just got those numbers? X is 120, right? So X, the banana area, is 120. It's just X. But strawberry is 2x, so double 120, 240. And each of the chocolate is 6 times x. So you take 6 times 120, you get 720, 720 for each of the chocolate quarters. Okay, what are they going to ask? Dale has the chocolate half. So that'd be 720, 720, 1440. D. 1440 for Dale's chocolate half. Is that okay? So I'm getting the 720. I take this 1.2x and I plug it in there times 6. 720, 720. Chocolate half, put the 720s together, 1440. All right, good? Feel free to speak up. I'm going to move as fast as I can, but... All righty. Dale, so, okay, I'm going to do the Dale cake again real quick. Dale, this was what? Banana, strawberry, chocolate, 720, 720, 120, 240. There's the Dale cake. In Dale's eyes, the piece below, what is that? That's half of the strawberry, half of the banana, isn't it? Everybody see that? 45 degrees, that's half of 90. Right? Everybody good? This is 90, so they went halfway through the strawberry, halfway through the banana, didn't they? See that? So that's half of 240, 120, plus half of the 120, 60. Right? I just took half of the 240, half of the 120. Add them up, 180. Is that there? Yeah, A. Answer A. Everybody see that? See how those slices are half the strawberry, half the banana, half the 240, half the 120, half the $2.40, $1.20, half the $1.20, 60 cents. Add those up for those two together, $1.80. That's what that's worth to Dale. Good. Stop me if you want to talk about it. All right. What would Carli do? What was Carli's thing again? Carli was it banana, strawberry, chocolate? Carli was, I'll look back. Carli was 720, 241. No, that's the wrong one. 6633. So Carli was $6, $6, $3, $3, right? When we did the Carli cake a minute ago. Talking Carli now. So which cut would Carli make to make equal value in Carli's eyes? Remember, that's what the divider always does. Come on back there, video. All right. So, right? That's what the divider does in the divider chooser method. The cutter always cuts fair in their value system because they know they get last pick. Right? So, what would Carli do? Would Carli cut right through the middle? Would she just go chopo right there? No way. That'd be $12 and $6 in her view. That would not be equal value. No way would she make division 1. Right? Remember, she's going to cut it equal money in her view because she gets last pick if she's the cutter. All right? Would she do the second one? Would she cut right through here? Well, that'd be 6 and 3. That'd make 9 on this side, right? 6 and then half the 6 is 3 is 9. And this would be 3, 3, 3. That'd be 9. Yeah, she'd make that cut. Do you see that? So that's a 9, 9 equal value cut in her eyes. Yes, division 2. She would not do division 1 because just this right here would only be $6. That's not half the 18. No way on division 3. Is that okay? Good, that makes sense. See how this one's the perfect one? Cut right through here, she splits this into 3, 3, right? So then what she does, it's 6 and 3 and 3, 3, 3, 9 and 9. Perfect cut. Equal value, her eyes. All right, let's go on with Malia. Okay, Malia buys a chocolate strawberry vanilla cake in figure 1 for $14. She cuts the cake into 6 60-degree wedges as shown in figure 3. Malia likes chocolate twice as much as vanilla, vanilla twice as much as strawberry. All right, so you start with the lowest one. Vanilla twice as much. So strawberry is the lowest one. Right? Yeah, strawberry's here, X. Vanilla is up here, 2X, right? Twice. And chocolate, twice vanilla. So 4X. Add those up. 4X, 2X, X equals the $14 cake. 7X is 14. Divide by 7. X is 2. So put that big in. This is $8 section, $4 section, $2 section in Malia's eyes, right? We good there? X is 2. Plug in the 2. Okay, now what does that mean about, we'll try to put this together. So what is the value of piece 1 to Malia? What is piece 1? Well, it looks like piece 1 right here. Piece 1, that's half of the vanilla, isn't it? See how it's half the vanilla? So just half of $4, $2. Boom. Got it. Am I good? Did that before? Good. I'll move on rapidly. Number 6. Get this out of the way here. Okay, number 6. What's it say? 3 players going to divide cake, blah, blah, blah. Which of the following is a fair division? Okay, if 3 people, basically 3 people, you need 33.3% or higher is fair. Remember how it works, right? You're taking 100%, you always divide by the number of people. If it's 3 people, that's 33.3% or better is fair. So circle the ones that are fair. The 40, the 37. Those are the only 2 that are fair. You with me? Only those 2 are 33.3 or better. Only those 2 would be considered fair. This is a tricky question. Let's go through it. This is like it's like a trick question.
What does it say? Those are different. I think that's a different question.
Oh no. Really?
Yeah.
Shoot. I hate it when that happens. So I got a different one than you guys, huh? That's not good. So yeah, you do. Look at that. I see yours. Yours is different. Yeah. changes at different times. I had different practice exams, and I gotta get. I had that problem with exam 1, but I fixed it. I didn't know there was another one. All right. Well, then I'll just write yours right here. All right. So we're under number 6, and it says for you guys S1, S2, S3. So chooser 1, chooser 2, and the percentages go 30%, 40%, 30%, 32. Well, I wonder if the answers are right. We'll see. We're going to see right now. If I can get moving here. All right. So same thing though. 30, right? Take 100%, divide it among 3 people. 33.3 is or higher is fair, right? So circle this, circle this. Those are the only 2 that are 33.3 or higher. Good. 3 people. Okay. Which of the following is a fair division? So A says chooser 1 gets S1. Does chooser 1 want S1? No. They don't even need to read any further. No way. Chooser 1 gets S2. Yeah, they'd like S2. Chooser 2 gets S3. Yeah, they'd like S3. They'd like that. That's good. And divider gets S1. Is that okay? What do y'all think? Can the divider have S1? Divider can have anything. They cut it, remember? Remember, the divider will have any, because they cut it. So they cut it so they think they're all fair. That's what the divider always does, right? So divider you don't even need to think about. Dividers thinks they're all great. So yeah, B's a good answer. So this one isn't, that's right, I got rid of that old trick one. That's right, that was an old trick one. That's why this has changed. It was an old weird one. Yeah, B's a good answer. I'm sure C is wrong. What does it say? C chooser 2 gets S1. Yeah, C's wrong. Chooser 1 gets S3. D's wrong. Yeah, so it is B. We all good with that? It's not a trick question anymore. I got rid of that old trick question. I updated it. All right, I think the rest will be the same. We will see. Okay, number 7. Oh, one of these big old things. Okay. Yeah, it looks the same on your handout as mine. Okay, so what are we supposed to do here? Agree to divide the cake fairly using lone divider, table below, blah, blah, blah. Which player was it? Okay, who was the divider? Whoever's a D. Yeah, whoever's same. D, and it's always D for divider. No, I'm kidding. I'm sorry. Just joking around. It's just whichever one has the same numbers, right? Because that's what a divider does. It cuts them fair in their value system. Okay. Assuming he plays honestly, what should be player C's declaration? So, in other words, what should player C says he thinks is fair? Which ones are fair? Your declaration means which ones you think would be fair. I would be willing to take piece 1 or piece 2 or whatever. That's your declaration. So what would player C declare as fair? Well, how do you figure that out? Well, I don't know. You got to add up C. $1.25, 75, 75, 75, and what? $1.50? What that is? It's 2 and 3. Is it $5? And then divide that by 5 pieces. So $1 or more. Any piece, it's $1 or more. See what I did? You all see what I did? I just added up all C's pieces. $5 divided by 5. You just divide by the number of people. It's 5 people. $1 or more is fair. Total divided by number of people is fair. $1 or more is fair. So C will declare anything $1 or more. So that'd be that piece or that piece. S1 or S5. There it is, A. Good. You might have got it by luck, but is it okay now? Does that make sense? Be exact on it. Add them up, divide by the total number of people. All right, which of the following is a fair division of the cake? Let's see. So we got to do fair for everybody? Because everybody's total is a little different. Yeah, all right. I guess we got to do that. All right, so yeah, this is a little tedious question. Do you realize that? Number 9. 9's a little tedious. You got to go through and figure out the ones that are fair for each person. So for person 1, let's do A over here. A, I'm going to add up A. What is it? Can I add them up? 1 plus 4 plus 3 plus 4 plus 3 divided by 5. So what is that? 7, 10, 15, $5, $3. Anything $3 or more is fair for A. So this one this one, this one. I'm going to underline them. We're getting too big here. Okay, so $3 or more. Boom, 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 boom. A likes them all except piece 1. Good? See how I did that? So see how I just added up A divided by 5. That's fair to A, right? Let's do B. For B, oops. For B, fair would be add up B. So that's 3.5, 4.5, 3.50, 3.5, and 5 divided by 5. I don't know, a bunch of numbers. 7, 8, 15, 20. 20 divided by 5, $4 or more is fair for B. So the $4.50 and the $5, that's it. Those are the only ones B thinks are fair. $4 or more for B. You guys see what I'm doing on this? Just add them up, divide by the number, total number of people. It's tedious. Let's do C. C, add them all up. $1.25, 75, 75, 75 and $1.50 divided by 5. So what is that? $2.50 and 3 is 5 divided by 5 is 1. $1 or more for C. $1.25, $1.50. All right. D, we've already said D is the divider. They're all equal, so D will take any of them. They're all fair to D. Finally, we're on to F. E. E. So where's E? I'm just running out of room here. So for E, we're going to add them all up. 1 plus 3 plus 1 plus 1 plus 4. Divided by 5. 1 plus 3 plus 1 plus 1 plus 4. Right. 5, 6, 9, 10 over 5. 2. $2 or more. Those two. For E. All right, so I've underlined everything everybody thinks is fair. Let's go through it. A. A gets S4. Does A want S4? Yeah. B gets S2. I'm just seeing is that as B underlined with S2. Yeah? Mm-hmm. C gets S1. Yeah? C likes S1. D gets S3. Yeah, D likes any of them. E gets S5. Yeah, that works. A works. But there's an all of the above or something, so I got to check B. So A looks good. A is a fair division. They'd be happy with A. It's all in there fair. Let's try B. B. A gets S4. Yeah, he likes that. B gets S5. Is that S5? B gets S5. B gets S5. Yeah. Mm-hmm. C gets S1. Yeah. D gets whatever. D gets anything. E gets S2. Yeah, that works. I've already got 2 of them that work. So it must be all of these are fair. It must be all are fair. Can't be none. Can't be just one. I don't want to check C. I'm sure it's good too. Does that make sense? They're all fair? That was a long problem. We got to move on. All right, number 10. So Joe and Bill want to divide a cake. Divider chooser. They draw straws. Determine that Bill will be the divider. Joe the chooser. Write that down. That's important. Bill's the divider. What does that mean Bill will do? Let's just stop right there. What does that mean Bill will do? What does the divider do?
Cut it equal to himself.
Cut it equal to himself, right? Bill cuts it 50-50 in his value system. That's what the divider does, right? Okay. Blah, 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 blah. Assuming that each player plays in which of the following statements cannot be true. You notice that little cannot? That's part of the thing right there. Cannot. That not matters a lot, right? Which of these is not true? Let's read it careful. A. Bill the divider, Bill believes that his share is worth 6%. Yeah, that's not true. That cannot be true. Bill will not think that. Right? He cut it. 50-50. That's what a cutter does. He will not think when he's done that his share is worth 60%. He will think it's worth 50. Exactly 50. Right? That makes sense? You guys okay with that? That's it already. I don't care what it says about Joe. I don't know what Joe thinks, but I know what Bill thinks. Bill's the cutter. Say, but I would check B just to make sure. B, Joe believes his share is worth 50. I don't know. Whatever. Joe does whatever. Bill believes his share is worth 50. Yeah, Bill definitely believes that. Can I say that cannot be true? No, that could be true. B could be true. Right? The only thing that cannot be true is that Bill the cutter will will think anything other than 50-50, right? That's what cannot be true. The cutter will think, I just cut it 50-50. That's what the cutter does. So that's what cannot be true. So it's A, right? Let's just double check. C, Bill believes that Joe's worth 50. Come on. Bill believes that Joe's share is worth 50. Joe believes his share is worth. Bill believes Joe's is worth. That could be, yeah. Joe believes his share is worth D. Joe believes his share is worth 60. Bill believes his share is worth 50. Yeah, see how it said 50 again. Whenever it talks about Bill, I don't know what Joe thinks. You know, he's a picker, whatever. He could have weird value system or normal. I don't know. But I know Bill. I know the cutter. He will cut it 50-50, right? So A cannot be true. Make sense? All right, I'll try to do it real quick. How about it? I know it's important. So first off, I'd put numbers up. You don't have to, but I think it'd make life easier for you. I'd put numbers. I'd go A1, A2, A3. And then I'll change my color maybe here. And then B1, B2, B3. Because they didn't number them. C1, C2, C3. And D1, D2, D3. All right. So how do you, I'm not even going to look at the questions, right? I'm just going to do the allotment, and then when I'm done, I'll go back to the questions. Remember how this works? So you first, number 1 on the left. So who's the first number 1 marker on the left? Well, A, obviously. Boom. There's, and that's A's candy, right? Then take the first number 2 on the left. What's the first number 2 marker? Well, it would be A, but A's out now, huh? A's out of the game. So first number 2 marker then is the D, right? The D marker. And how far will you go with that D marker? To the other D. That's the D section. That goes from D to D, right? You're only giving people the sections they've marked out. That's the common mistake. People go back too far. You don't just go back to the last circle thing. You go back to the last D, because it's a D to D, right? You're always giving them their section. That goes D to D. So then you go to the first number 3 marker on the left. Who's the first? And D's out. I got to cross out the D's. D's out. A's out. They're done. Who's the first number 3 marker? C right there. How far do you go? C to C. Right? That's the C section. That good? You're grabbing the first number 1 marker, first number 2, first number 3. But every time you only go D to D, C to C, A to A, right? You only give them their section that they've marked off. Don't go past it. And always, you know, once somebody's done, they're out of the game. So who's left? And the last, the last you go right, don't you, on the last one. We got A, D, C, so there's B, go right. So that's B's section. The very last one, you go right. So the other ones are leftovers. So item 8, so here comes our questions. Item 8, it's leftover. See it? Item 9, it's leftover. Item 15, leftover. Those are 3 leftovers. It's like trick questions. Are you doing those thinking, is this wrong? Is Sharon tricking me? Leftover, I just get these off Publisher's website. Leftover, leftover, leftover. Test bank on the website. Good? We good there? All right, 15, 16. Let's see, 20 minutes. Okay, standard divisor. Remember how to come up with a standard divisor. It's total population divided by number of seats, right? So total population, if you add those up, what do you got? 67,200 plus 78.3. All right, 78.3 plus 78.3 again. No, 73.8. 73, 73.8, and 80,700. Divide all that up. I've got 3 with a bunch of zeros. 1, 2, 3, 5 zeros. So 300,000 divided by, what's the number of seats here? 100. 100 seats, cuts off 2 zeros. It's 3,000, isn't it? A? Standard divisor is 3,000, A? Okay. Standard quota. How do you figure the quota? Well, you just take C, which is 73,800, and you divide by the standard divisor. That's what the divisor's for dividing, right? Remember that? 73,800 divided by 3, 1, 2, 3. is 24.6. 24.6. D, standard quota, right? That's how you do all the standard quotas. Now, then they want us to do the Hamilton thing, okay? We'll do the Hamilton thing. Good with that? I'll go to a fresh screen, we'll do Hamilton. 3,000 was my divisor, okay. Okay, so for Hamilton, I'm gonna do A, B, see, well, I need a little more room there, don't I? So, okay, so A, B, C, and D. Take each of them. What's A? 67,200. B is 78,300. C is 73,800. And D is 80,700. I divide them all by 3,000. And I'm getting 22.4. 26.1. What was this one? 24.6? I think, right? And then 26.9? Okay, so what do you do with Hamilton? So we're going to do Hamilton, then we'll do Jefferson. So what do you do for Hamilton? Do you remember? Yeah, Hamilton. So Hamilton down. Round them down. So this would be 22, 26, 24, even the 24, even the 26.9. Down, 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 down. And then add up. What's the total? Total of those, if you total 22, 26, 24, and 26, 48 and 50, 98. It's 98, so that means 2 to go, right? It's supposed to be 100. 100 seats on the legislature. So 2 seats, got to give back to who gets the 2 seats? The 2 highest decimals, right? 0.6, 0.9. Get a seat, get a seat. So 25, 27 for those guys. The other 2 stay where they're at. There's the 100. Hamilton's was the simplest, right? You don't have to pick a new divisor or anything like that. You just divide them all, add them up, say, okay, we got 2 extra seats, 2 highest decimals, get them. 0.9, 0.6. Boom, boom. So the total should be 22, 26, 25, 27. So let's see, 22, 26, 25. Oh, it's A. Looks like it's A, huh? Good. Ready for Jefferson? Questions on Hamilton? We're good. Okay, I'm going to go over. So 22.4, I'll just go back and forth. So let's do Jefferson now. So we get A, we get B, we get C, we get D. And, okay, 67, 200, 78, 300, 73, 800, 80,700. Okay, now for Jefferson, remember, do you remember? You put it on your 3x5 card. For Jefferson, you pick a lower standard divisor and round down. Remember, Jefferson's the downer. Lower down. Adams is the higher up, right? So divide by some lower standard divisor. What was the other standard divisor we had? It was 3,000, that's right. 3,000. Something lower. How much lower? I don't know. 2,900, maybe? What you guys try? Does that work? I'm going to say 2,900. Divide them all by, I'll put it down here. I'll try dividing them all by 2,900. It's lower than 3,000. Just giving it a go. We'll see what happens. 67200 divided by 2,900. I'm getting 23.1. I'm getting 27. 25.4. And I'm getting 27.8. All right, so now what are you supposed to do with Jefferson? Round them all down. It'd be 23, 27, 25, 27. And what's the total? That's too much, huh? It's 102. It's 102. So it's too much. Too many seats. We don't have 102 seats to pass out. It's too much. What do you do when it's too much? You actually go higher. Remember, because a higher divisor, dividing by more brings the numbers down. So instead of 2,900, I'm going to try 2,950. I can't go above 3,000 though, right? Because you know Jefferson is below the original. It's below 3,000. But he must be higher than 2,900, right? So if this is too much, divisor higher. Must try a higher divisor. Do you remember that? That's counterintuitive at first, right? It doesn't seem right at first, right? If your total's coming out too much, you need to actually divide by a higher number, because dividing by more brings numbers down, doesn't it? So you need to divide by a higher number. So if it's too high, go higher. If it's too low, go lower. It doesn't seem right at first, but it is. So you want to put that in your 3x5 card, right? So try a high. If it's too much, then try a higher divisor. So I'm going to try 2,950. So let's do that. So I'm going to, this thing's really having problems. So, okay, come on. So I'm going to go back, erase this, came out 102. So I'm going to try 2,950. I'm going to do all these numbers now by 2,950. So now I'm going to divide by 2,950. So go back. So 67200 divided by 2,950. I'm getting 22.7. So that's going to round down to 22. We already lost one there, so that's looking good. But we don't want to lose too many. Might be too many. 26.5. So that's going to round down to 26. We've already lost 2. Yeah, we're going to lose too many. Probably. 25.01. Ooh, we stayed at 25. Okay, we didn't lose one there. Barely. Barely. Okay. If this one comes through, we got it. Ooh, we got it. 27.3. So that's going to round down to 22. 26. We lost one each in those spots. But this stays at 25. This is 27. Add that up. It's 100. It's perfect. So there's Jefferson. There's the answer for Jefferson. 22, 26, 25. So 22, 26, 25, 22, 26, 22, 26, 25, 26. D, huh? Is that okay? Let me pause there. I'm going quick, but I don't want to go too fast and not make sense. Is that okay? Does that make sense how I figured out that Jefferson total? So again, Jefferson is a lower round down, so I picked lower than 3,000, which was the standard. So I tried 2,900, tried it, came out too high. Too high means actually go higher on your standard deviation, so I went up to 2,950. Not higher above 3,000, though. That's a mistake I've seen students make in the past. They'll go above 3,000. No, Jefferson is going to be below 3,000. So I went to 2,950, and that worked when I rounded them all down. Came out exactly 100. Okay? All right. Okay, so let's do Adams and Webster. So again, we've got the A, B, C, D thing. Got A, B, C, and D. And I can't remember what they are. 67,200. 78,300, 73,800, 80,000. Is it 700? Yeah. 73, 73,800. Yeah, good. All right, so I'm going to do Adams now. And Adams says higher divisor, round up. He's up, and away, right? He's higher divisor up, where Jefferson is lower divisor down. So higher than 3,000. How about 3,100? Maybe I should do 3,050 after my last experience. I don't know. I'll just try 3,100. So I'm going to divide by 3,100. I'm going to take all those, divide by 3,100. And I'm getting 21.6 or 7, whatever. 78,300 divided by 3,100. 25.2 actually. Doesn't really matter. I'm rounding the whole thing up. 73,800 divided by 3,100. Getting 23. Ooh, come on, no scribbling. 23.8. And then 8,700 divided by 3,100. I'm getting 26.03. Round them all up. 22, 26, 24, 27 actually. That rounds up. That's going to be too much, huh? Is that like way too much? Like crazy too much? What is that? 22, 26, 24, 27. Oh, no, it's under. It's 99. That's too low. That came out 99. Yeah. Too low. So too low, go lower actually. It sounds counterintuitive. Lower on the divisor. Because if you divide by less, numbers go higher, right? So I need a lower standard divisor. So yeah, I probably should have done 30-50 from the beginning. But it's close. Is that true? Let me think for a second. Yeah, it's really close. Look at this guy. Look at this guy right here. He's on the border. If he was just a little bit lower, instead of 26.03, if he was 25.9, then he would have rounded. Oh, wait. I want to go higher. I'm confused. I don't know. I'm going to start at 30-50. I get turned around. I'm going to do 30-50. I'm going to try it again. 30-50. See what happens. I think I'm close. I don't know. Maybe I'm thinking backwards. I'll just try 30-50. All right, so here we go. 30-50 now. Divide them through. This is tedious stuff here. 7,200 divided by 30-50. 22.0. 78,300 divided by 30-50. 25.7. 73,800 divided by 30-50. 24.1. 8,700 divided by 30-50. 26.4. Round them up, right? Was that first one 7,200 divided by 30-50? It's 22.03. So this rounds up to 23, 26, 25, 27. Add them up. 2, 8. Is it 101? Did you guys do this one? 101. It's too high. It's too high. Go higher. Higher. It's too high, go higher. So like 30-75, this is where these get painful, right? It's 3,100 was, I need to go lower, but it's higher than 30, so like 30-80 or something. I gotta do it again. Look at the clock. I'm gonna try like 30-80 now. Do you understand what's happening, right? This came out 101. This came out 101. The other one came out 99. So the other one was too low, go lower. This is too high, go higher. It's higher than 30-50, lower than 3,100. I'm going to try like 30-80 or 30-90. I think it's close to 3,100, but just not quite that high. All right, one more time. This has got to do it. So I'm getting tired of it now. So this is long. So save these for the last maybe, you know, when you take the test on Wednesday. So 30-80. Here we go. 30-80. 21.8. Oops. Divided by 30-80. Gotta have a good calculator. This is tedious. 25.4. 800 divided by 30-80. 23.9 divided by 30-80. 26.2. Round them up. 22, 26, 24, 27. Is it 99 again? Stinker. 99 again? So it's too low, go lower. It's lower than 30-70. I'm really tired of this now. So it's like, what, 30-60 or 30-70? I got to make this work. All right. Let me try like, so you understand that's too low. This came out 99. Go lower. Well, it's too low, go lower. Yeah, so you got to divide by like 30-70 or 30-60. I don't know. It's really close in there. Right? You see what I'm saying, guys? Do you hate this one as much as I do? All right, we can't be sure until it works. I'm going to try 30-70 now. So 6,7,200 divided by 30-70. This one's really touchy. 21.8. 78,300 divided by, what was it, 30-70? 25.5. 73,800 divided by 30-70, 24.03. That one comes out really close. Maybe he's the issue. I'm going to try to pay attention. Let's see. 26.3. So this is 22, 26, 25, 27. That's it. That's it, isn't it? That's it. 100. There it is. So Adams, 22, 26, 25, 27. It's D. 30-70. I don't know. It could have been that 30-60 would also work. I don't know. It had to be something between 30-50 and 30-80. Had to be between those two. It's pretty picky. Do you see how that worked? Back and forth. So I got something to work. All right. Webster, my goodness. Webster's usually easy. So Webster, I almost got these memorized now. What are these? 67,200. So A, B, C, D. 67,200, 78,300, 73,800, 80,700, I think. Yes. Okay, now what do you do with Webster? Remember Webster? You start with the standard divisor. Just see if that works. That usually works. Just divide by the normal one first and round what? What does he round? Off. I like his method. He rounds off, 0.5 up, 0.4 down, instead of everybody up or everybody down like Jefferson Adams, right? So just divide them all by you start with the standard with him, and you hope for the best. In fact, I know it's going to work because I observed it the first time. So 22.4, that'll round off to 22, right? 78,300 divided by 3,000, and 26.1, that'll round off to 26. The next one, 24.6, will round off to 25, huh? So Webster rounds off. I like Webster. And that's pretty much the method we use now. Something like Webster's. I told you whatever it's called. 26.9 rounds off to 27. Add that up, that's right. So Webster, 22, 26, 22, 26, 25, 27, B. Webster's B. So Webster's quicker. It's Jefferson and Adams. It's a big pain. Good with all that? I'm going to move on. Okay, 24. Certain apportionment problem. State X as a standard of 48.9. The final apportionment is 47. Oh, look at that. Remember what that means? If 48.9, that should round up to 49 or down to 48. If you go outside that zone, you're doing something bad. They got 47. It should never have come down to 47, right? Remember, the standard is what they truly deserve. They truly deserve 48.9 reps. So any of these methods should not cause them, should be 48 or 49 for them, right? Round up or round down. They should never be out of their rounding zone. If they do, that's called a lower quota, because they went down low, right? Violation. Is that what's, okay, now which one can do a lower quota violation? Well, I gave you that chart, right? I don't know, to tell you the truth off the top of my head. Who can do a lower quota violation? Webster or Adams? Webster or Adams? They don't even talk about Webster, so it's Adams. It could be Adams. Make sense? That's on the sheet. So if you didn't get that, I've got it up here. I'll come grab it here in a few minutes when we're done. So that's Adams that can do lower violations on the quota. You understand how the quota was for, like, what they should get 48.9. They should up or down, that's all. You should round up or round down. Anything other than that is bad. So 25, 48.9, they got 50. So 48.9 again should go up to 49 or down to 48 at most. If they went up to 50, that's an upper. That's an upper violation. Who does the upper violation? That's Jefferson or Webster. They don't talk about Webster here, so it's Jefferson. That's, again, off that chart that you should put on your 3x5 card. We good with those? Let's go to 26. Well, I got to see it a little bit better. 26. Under certain apportionment, state received 52 when the total number was 334, but only 51 when there was more. They got less when there's more. They got less when there was. That the Alabama? Again, I'm a little confused. Okay, let's put that in 3x5 card. That's the Alabama, right? Because yeah, there were more. Yeah, that was the Alabama. There's more and they got less. That's the Alabama paradox. Put that in your card. 27. State X received 51, 19. 10 years later, the population increased. That's the population, right? That's obviously. Don't even need to read anymore. Populations, da-da-da. Population. Good on that? .28 says, well, that's a long story. The mother wishes her 16 pieces of candy, da-da-da, da-da-da. Abe 9, Betty 4, Cindy 3. However, just before, she discovers that a neighbor has been helping since Dave worked. Mother, okay. That's the new person shows up. Right? The neighbor. That's the news. Remember, the new state came in and it made other people shift. That's what they're talking about. So look that one up, and we have that in the notes. Whenever a new person shows up, that's like what happened with the new state came in. 29, mother wishes, same kind of thing, based on using certain, based on the time. Abe ends up with 9, Betty 4, Cindy 3. Well, I don't know what happened. Okay, so Abe was going to get, so maybe we better track him. Abe was going to get 7.8. Betty and Cindy, Betty deserves 4.8. Cindy deserves 3.4. But in reality, Abe got 9, Betty got 4, and Cindy got 3. Look what happened to Abe. Abe violated the upper quota. Abe violated the upper quota. A. Abe should have went up to 8 or down to 7. He went up to 9. It's an upper quota violation, right? Remember, any number should round up or down. Beyond that is a violation of what we think of as fair, right? Upper quota violation. All right, I did all of them but the other cabin one. So those we did those in the notes. So that's there for you.